Question 8. Now there are other ways of doing this, but I think the simplest is just via Pythagoras. So if we just draw a quick sketch to gather our thoughts, we know that the line L has gradient -2, so that's going down quite steeply. Let's just set A here, being the coordinate 3, 5, and we know the distance to B is 6√5, so that can either be up the line to what I've called B1 or down the line to what I've called B2. Now we don't know the length of the base and the height of these triangles, but what we do know is that the gradient, and because the gradient is -2, that this length here is twice as long as this length here. So this then gives us Pythagoras. We can say x squared plus 2x all squared equals 6√5 squared, which I've done over here. Remember, 2x all squared is 4x squared, so gathering up the left we get 5x squared. Remember, 6√5 squared is 6 times √5 times 6 times √5. 6 is a 36, √5 times √5 is 5. Now I've just left it at this. I haven't bothered working it out because I can see I'm going to be able to cancel the 5s in a minute. So that becomes this, the 5's cancel, x squared equals 36, so x is plus or minus √6, but obviously x is a length, so x must be plus 6. Now bearing in mind that this is 6 and this length is therefore 12, we can now work out our two coordinates. So to find B1 as I've called it, going back from A, we've got to take away 6 from the x coordinate. 3 take away 6 is -3, but we've got to add 12 to the y coordinate. 5 add 12 is 17. Similarly down here for B2, from A, from the x coordinate, we've got to take away, we've got to add 6, for the x coordinate and take away 12 from the y coordinate, giving us 9 minus 7. So it could be done other ways. You could work out the equation of the line and other stuff, but I think this is by far the easiest way.